Okay, thank you. Is screen visible now?
Yes, sir.
Fine. So in this C language construct of a assignment, which is a variable and value, the first statement will give us the basic idea behind how an assignment statement or construct will look like in C. Now value is kept in angle brackets. So anybody who reads the first line will come to know that fine, value is not a single value, it is further defined. How it is defined? It is defined further as maybe a plain number, which is a terminal, or it can be an expression. Again, expression can be further expanded because we have kept them in angle brackets. Again, expression is defined as a number. So it can be number or number plus number. We just precisely written here. If you read any document of a compiler design, you feel there is so much complexity involved. So expression can be what? Number plus number, number minus number, number multiplication number, number division number, all possibilities. Again, it can be expression plus number. There is so much of integrity, what complexities have been added for the expression, because you can write any big sentence or assignment operation with a plus b within parenthesis, one more parenthesis. You write any big, any complex type of expression, your C language will accept. If that is the case, how it is internally represented? To write a grammar for assignment statement is itself is very complex. We have written here only for your understanding that expression is equal to number, but expression is not a simple number, is it? Number is going to be, expression can be number plus number or number plus expression. You can write say a plus b plus c. The b plus c you keep in parenthesis. What is happening now? A is a number, b plus c is a expression. So expression can be sub expression. It can contain some sub expression. So if you define, it becomes too complex. Probably we'll take some examples later when you go to Lex and Act. You will appreciate how expression has been defined. So that means one should know how these values for a variable, that is a value parameter, can be defined in detail. So far we have used int a is equal to 10, at most int a is equal to 10 plus b. We have not explored with any complex expression, but possibility of using complex expressions are there in the programming languages, and your compiler is designed such that you can have any level of complexity, a plus b within parenthesis, one more parenthesis. You can use as complex as BODMAS what we have in mathematics. So still your C is going to value that. Problem it was seen in infix, postfix notations as well. You can have a very complex expressions, and those expressions are going to be very neatly and easily processed by the programming languages. And this is just an example for you to represent this. We are at the design of a compiler. So before designing a compiler, you need to have some process or mechanism to represent all these. So when you design a C compiler, let us say, you should take everything of a C construct into consideration. You have to define things like this. Then you will understand how to channelize your efforts so that actual compiler design can be properly made. So this is the idea behind how BNF grammar is going to be of some help. So BNF grammar will help you to understand how internally the complexity of a particular construct of a language can be built. Okay. So using angle brackets. Now let me know whether all those 4 points are covered in this. What are the 4 points of BNF? Starting symbol, terminal symbols, non-terminal symbols, grammar. Do you find all these 4 in this statement? We have 3 statements here. So can I say it is a BNF grammar? What is a BNF grammar? BNF grammar should have these 4. A starting symbol, rules for the grammar, terminal symbols, non-terminal symbols. So do we have all this in these 3 statements now? Where is the starting symbol? What is the assignment operation of a C programming? It is a variable, equal operator, value. Do we have that with us? Do we have that here?
Yes, sir.
So starting symbol is taken care. Next, Do you have terminal and non-terminal symbols? Okay, if you don't want to answer, I am also not interested. I'll go further. Fine. Next. So let us get into the using these grammars. Next part, that is the lexical analysis. We know that grammar is going to be part that we are going to use in the lexical analysis. Let us see how this grammar can be used in the scanning process or the tokenization process. Okay. Fine. So let us assume we are going to define an identifier. So look at this particular identifier. So what is an identifier? Identifier is a set of characters. For example, I want to define an identifier. What is an identifier? As the name says identifier, it is some name. For example, int A, int salary, int student, int name, int city. Like that I can write any characters. If you remember, each language has its own restrictions in naming the identifiers. Normally, we have some 3-4 standard restrictions or characteristics for a identifier. What are they? Each identifier should start with a character, which is an alphabet, and it should be always starting, better say, lowercase. And we should not start a identifier with a number, and we should have only alphanumeric characters along with underscore as far as the identifiers are concerned. Like that, we have certain rules and restrictions in naming the identifier. So you have to frame that identifier rules, and accordingly we have to write our rule. And when you write that rule is going to be used as far as the programming language constructs when it comes to an identifier. So look at identifier, how we have defined here. So we have defined identifier as a character or character followed by identifier. So this looks a bit complex, but you should understand this properly. So this is called as a recursive definition for a identifier. If you remember, a recursion is nothing but a function that is called within itself. So similar to that, I am defining identifier. How is identifier is defined? It is defined within itself using same identifier, meaning that identifier is having a recursive definition here. So identifier can be defined as a single character like int A, or it can be int student. So when I write student, I have a S, T, U, D, E, N, T. Each of them are the characters. So I have a S, then student, S, T, U, D, E, N, T. They are going to be other set of characters. That means an identifier is not only a single character, it is going to be a group of characters. So if you look at this identifier definition here, can it take numbers as part of the identifier definition?
No, sir.
No, because we have stopped character defined at either A, or B, or C, or Z. So if I have written 0 to 9, then I would have used 0 to 9 as part of my identifier. So if any designer has designed a identifier like this, then you cannot define that identifier in reality with numbers, because numbers are not part of the rule here. So this is the rule. So what is the starting symbol? We have a starting symbol as identifier. We have a character, which is a rule here, and we have a terminal and non-terminal symbols here. So this is going to be the best fit for a BNF grammar. So you have to take a call depending upon the requirements of a compiler design, how to define each of the constructs. If you say my identifier should not contain numbers, you can define like this. If you say my identifier can contain numbers, you can define accordingly. So whichever is required, accordingly our grammar can specify those requirements. That is the idea behind these grammar notations, and we'll see how these grammars can be categorized or can be designed using our finite automata theory. Okay. Now, as we know, each token is internally given a number, internally represented with a number. For example, if I defined a character here, A, B, C, all small case ABCs are different from uppercase. We know that, case sensitive. So each one is given a number, because when you see that lookup table in the lexical analysis, each character will be compared like our opcode table, whether the character what I have used is part of the character set of the language or not. While doing that, a number will be generated. That number is the outcome. So every time that function, we have seen YYLEX, no? That YYLEX is the one which generates this particular code and returns the corresponding number. When a corresponding number is returned, that means that that particular character is a valid character. If corresponding number is not returned, something else is returned, then probably that character is not a valid character. That is how internally the mechanism is designed to understand whether the characters that we have used are a valid characters or not. Okay. So when I take, for our given example, if I take ABC, XYZ as some of the examples, how internally it will be represented? It will be represented as a token name. What is the token name? Integer is the token name. What is the code? We have just defined A as 100, let us say, and identifier name is ABC, XYZ, PQR. So when I see ABC, it will return some code number, one for A, one for B, one for C, like that. So after compiling everything, it will return one of these numbers, which are valid numbers. And when valid numbers are returned as a part of the function, then we make sure that the given data is as per the character set of the given programming language. Okay. Now, so the main part here is now how to use automata for lexical analysis. Is very, very important from exam point of view. They will ask you design a scanner or a lexical analyzer using finite automata. So we know that for lexical analysis, grammars are very important, and these grammars are going to be redefining or maybe giving a room for us how we can visualize the characters or the rules of the particular construct of a programming language. By doing so, we can easily visualize, and any corrections we can bring into the design part. So before a designer gets into the real design of a compiler, to understand how the lexical analysis need to be carried out, probably the designer can go through this finite automata, which becomes a handy tool for them to analyze the character set along with the rules that come along with the character set to recognize whether the program of the user or the source program is in line with the given programming language or not. So finite automata is basically going to help the designers in figuring out their scanners or a lexical analyzers. So what is finite automata? Okay, so finite automata is made up of certain states. What are the states? A state is a place. Probably in software engineering, you might have seen a state diagram. A state diagram is a what? A state diagram represents what is the current state of activity of my system. For example, if you go to a bank today at 10 o'clock, what is the state of the bank at 10 o'clock? There are 5 customers, there are 6 employees, there is a 2 lakhs cash in the bank. That is the state of the bank at 10 a.m. You go around 1 p.m. in the afternoon to the same bank, you see 8 employees, you see 25 customers, you see 10 lakhs cash. So what happened now? What was the state at 10 a.m. is different at 1 p.m. meaning that state is going to change at different time intervals differently. So state keeps us understand at given point in time what is the position of that particular system. The same case here, when I take the input, when I take, for example, A, B, C, X, Y, Z as my input for identifier, when I give A, what will happen? When I give B, what will happen? When I give C, what will happen? So like that, I'm going to transit from one state to the another state on the subsequent supply of my input. So once the input is given, accordingly, I will move from one state to another state. So how is this helping me to understand whether my data is valid or not? So this will help us to transit, as we know, from one state. The first state is going to be starting state to the last state, which is a final state. So when my input is given, I am at the starting state. Based on the input is given, I start transiting, I start moving from initial state till some next state or maybe subsequent state. So I make sure that entire input is completed, processed rather. Now I check after entire input is processed, where am I? If I have reached the final state, I say that my input is valid. I repeat, starting from the starting state, processing the entire input through the subsequent states. If I can reach the final state at the end of the input, then I say my given input is a valid input. Otherwise, if I have struck in between, by not reaching the final state, then I say that my given input is an invalid input. So that is the idea behind finite automation. That is what we are going to use now. So we have a set of symbols for them. So what are those symbols? And those symbols are going to be circles. We have a circle to represent. I will just shift to another mode of presentation. Let me know whether that screen is visible to you. Hope the screen is visible.
Yes, sir.
Yes. So what I have written now? Are you able to see what I have written?
Yes, sir. Big welcome, big O.
Good, nice. So that means we are able to see the screen. So this is the symbol for a state. So this is the symbol for the state. A circle represents a symbol for the state. And everything is state for me. And the arrow mark represents transition. That is, I move from one place to another place. Okay. Assume I have taken some 3 states here. All are states only. But how do I identify which is the starting state, which is the final state? So starting state is represented with an inward arrow. When I write an inward arrow, I call this as a starting state. A normal state is like this, just a single circle. And how do I know final state? A final state is represented with 2 circles. So this is the notation what we have in finite automation. So basically, automata theory, when you write a diagram, which is a visualization to understand whether my input is matching as per the requirements of the grammar or not. To visualize before I get into the actual code designing, I will write a diagram and to make sure that for this input, how the behavior is going to be. So this is a trial and error method or a combination permutation type of way where I can arrive at the final design before I go to the final diagram before I go to the actual design. So that is going to be the support what we get from this finite automation. Now, so initial state or a start state is a circle with an inward arrow. Then any other state will be a single circle. Then a final state is nothing but 2 circles enclosed with it. So this is the idea or the symbols what we have while writing the finite automation symbols or finite automation diagram. So let us take an input now. I will take a diagram and let us see how that is. Normally, the states will be given numbers. For initial state, I can say Q1. For final state, I can say Q1, Q2, Q3. So like this, I can keep on giving numbers. So initial state can be Q0, or you can give any numbers. Normally, it is used as a convention Q0, Q1, Q2, Q3. We can keep on writing. So final state can be any number. Final state is represented with the symbol, that is 2 circles. Q1, Q2, Q3 is for our understanding, to make sure that which is a initial state, which is the subsequent state, which is the final state. Now I will take a diagram here. Let me understand what this diagram is going to be. Okay. So if you have a pen and paper, probably you can also try. So what is this now? What do you see here? How many states are there? How many states do you see?
4.
Q0, Q1, Q2, Q3. So which is the initial state?
Q0, sir.
Q0. Why? Because it has a inward arrow. So can I make Q1 also initial state? So for any diagram, initial state will be only one. It can be anywhere. If not at Q0, I can make at Q1, I can make at Q2, I can make at Q3. But at any point of time, there should be only one starting state. Okay, next. So I am at Q0. From Q0, I need to move to Q1. When should I move to Q1? So what is missing here? What is missing? Under which circumstance I can move from A to B? Sorry, Q0 to Q1, right? Yes or no?
Yes, sir. Yes, sir.
Yes. So now I have to mention, when I am at Q0, upon which input I can move to Q1. I say A. When I receive A, when I am at Q0, then I can move to Q1. Then I say, when I am at Q1, if I get B, I can move to Q2. And I say, when I am at Q2, when I get C, I will go to Q3. When I go to Q3, I am said that I have reached my goal or the destination. Okay, is that clear now?
Yes, sir. Yes, sir.
Fine. I will take some examples now. Tell me if this example is a valid example or not. I have taken ABC. When I give ABC, how to start now? How to analyze this? A is the starting symbol. When I give A, I am here. So starting symbol is Q0. At Q0, A is given. When A is given, is A is valid for Q0? So what will happen for Q0 when it is receiving A? It will go to Q1, right? Sir, no. Yes, I need interaction, otherwise it will be waste exercise. Next, when I get A, I have reached Q1. When I am at Q1, what is the next input? B. B is given. So when I am at Q1, B is given, and when B is received, it knows where to go. It goes to Q2, right?
Yes, sir. Yes, sir.
Yes. When I am at Q2, I am giving another input C, and at Q2, when C is received, it goes to Q3, right? Okay.
Yes, sir.
Now input is over, or still any input is there?
No, sir.
Input is complete. When input is complete, where am I? Have I reached final state?
Yes, sir. We are in
Yes, sir.
So can you say it is a valid input?
Yes, sir.
Let me take second input. Tell me what this input is. Is it valid or invalid?
Invalid, sir.
Invalid. Why? Because when I see A, I will go to Q1. When I see B, I go to Q2. Again, I am getting B. When I get B, I don't know what to do at Q2. So Q2 can go to Q3 only when it gets C. But I am getting B. So this is a invalid. Hope all of you are following.
Yes, sir. Yes, sir.
Okay. I will take another one. What about this? A, B,
Shadow,
C.
sir.
Huh? Shadow? Okay, now?
Shadow, sir. Not.
Now? Now visible or not?
No, sir.
Okay. Is it visible now? I have written something?
Yes, sir. Yes, sir. Visual, sir.
Yeah, okay, maybe. Okay, fine. So A, B, C, C is my input now. Is it valid?
Invalid, sir.
Invalid.
No,
Why
sir.
again? ABC is valid. Up to ABC, it's fine. It goes to Q3. But when I give C, it doesn't know what to do. It doesn't know what to do. So it will be entering into a state where there is no value at all. So you may question me. So ABC is over. I am at final state. Even the last C is over. I am still at final state. Is it a valid statement? No. When I am seeing second C, I can't say I am at final state because up to first C I am at final state. When I see the next C, I don't know where to go. Meaning that input is there, processing is pending. I may be at final state, but input is not completed. When I say input complete means input processing is complete. But here C is extra here, so processing is incomplete. So when I say valid or invalid, input processing should be complete and I should have reached the final state or any other state. Then only I can say my input is completely over. But in this case here, the additional C what we have here is incomplete. It is not processed. Thereby, this is a invalid way of looking at the grammar. Let me take one more now. Hope the screen has become blank. Yes.
Yes, sir.
I will rewrite the same diagram. Let us see. Let me know if something is not visible to you. I am trying for the first time. I don't know how it is. So any change between the previous diagram and this diagram? No.
No, sir.
So I am injecting some complexity to the diagram. Yes?
Yes, sir.
So now tell me, which are all valid here? ABC is valid?
Yes, sir.
Let me. So ABC first is valid. So first one is valid anyhow. There is no change. How about second one?
Valid, sir.
So A, B, C. Again I am seeing C. This is called as a self loop. A C, if you look at Q3, I have written a C again to itself. This is called as a self loop. Self loop means it will be with itself. That is called a self loop. So when I see additional C, I am still in final state. My input is over. I have reached final state. I can say it is a valid. See, look at the previous diagram. In the previous diagram, we said the same input is a invalid. So meaning that, so depending upon how you need to validate them, you have to keep on trying this particular diagram. So this diagram will help you in the final design later. Okay, next. How about this third one? ABBC.
Invalid, sir.
ABBC invalid. We are at A, we are at B. When it comes to B, it doesn't know where to go. It is a invalid. So input is not completed, but we are stuck in between. Next. AB.
Invalid, sir.
Invalid. So A, you come to Q1, B, you come to Q2. Again A is coming, you are stuck in between. So it is invalid. Next, ABC.
Sir, invalid.
Invalid. First ABC, you have come to Q3. Again A is coming. You know where to go when B is there or C is there. You don't know where to go when A is there. So it is a invalid. How about this?
Sir, valid, sir.
So ABC, BBC, A, B, C. We have reached Q3. Then B is there. You have come to Q1. One more B is there. You have come to Q2. C is there. You have come to Q3. So you have reached final state. All inputs are over. So it is a valid. How about this one?
Sir, invalid, sir.
Invalid, because from Q3
Doesn't know where to go from.
you come to Q1, but you are stuck at Q1 because next character is C. There is no route for C, so you are stuck. So input is also not processed. You are not gone further. You are stuck somewhere. So it is a invalid. So this is how the processing of a finite automation is carried out. Okay. Any doubts for automation, finite automation?
No, sir. No.
No, sir. No, sir.
No, sir.
Fine. Now, so I'll give a small exercise. Try whether you can write a automation diagram like this. Okay. Take one. During that, let me take attendance. Let me see how you can write that. Write finite automation for the following. Write finite automation for the following. First one. Recognize identifier beginning with a letter, within brackets alphabet, followed by a sequence of letters or digits, followed by a sequence of letters or digits. Try. Let us see how you will be able to do that. Meanwhile, I will take attendance. Asta?
Present, sir.
Abhinav? Aishwarya?
Present, sir.
Ambarish?
Yes, sir.
Anu?
Present, sir.
Arbaz?
Yes, sir.
Arjun?
Present, sir.
Ashok?
Present, sir.
Binita?
Present, sir.
Bhargavi?
Sir.
Bhavisha?
Present, sir.
Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha,
Present, sir.
Deepika LG,
Present, sir.
Deepika MB,
Present, sir.
Murli Krishna,
Present, sir.
Gangubai,
Present, sir.
Guria Kumari,
Present, sir.
Harshit,
Present, sir.
Junjar,
Present, sir.
Kavya,
Present, sir.
Kishore, Kishore, Lata,
Yes, sir.
Manisha,
Present, sir.
Manjunath,
Yes, sir.
Nayana,
Present, sir.
Nilanjan, Nishant,
Present, sir.
Pavitra,
Present, sir.
Maithili,
Present, sir.
Priyanka,
Present, sir.
Pavan,
Present, sir.
Akash, Rajeshwari,
Present, sir.
Rakesh,
Present, sir.
Ramya,
Present, sir.
Rashmi,
Present, sir.
Ravishankar,
Yes, sir.
Rizwan,
Present, sir.
Vishal,
Present, sir.
Savita, Shruti,
Present, sir.
Sneha,
Yes, sir.
Kurti,
Present, sir.
Nidhi,
Present, sir.
Srinivas,
Present, sir.
Sunil,
Present, sir.
Vaishnavi, Vinny. Okay. So, could anybody try?
సార్ మీరు సార్
Hello?
క్లోజ్ చేయండి సార్
మీ క్లాస్ ఉంది ఇప్పుడు
సెకండ్ అవర్ ఉంది
2 minutes ఇంకా ఉంది టైమ్
ఓకే ఓకే మీరేమో మర్చిపోయినారేమో అనుకున్నా నేను
లేదు
ఓకే ఓకే నో ప్రాబ్లం మాకేలా ఈరోజు 1 అవర్ కావాలని
తొందర లేదు
సో ఇది నేషనల్ ప్రాబ్లం ఉంది కదా ఇట్ విల్ టేక్ 1 అవర్
Okay, then go ahead. Now, just wanted to know, hope any of you could do that particular problem. Finding it difficult or able to manage
Sir.
that automated diagram?
Sir.
Yes.
Sir, if the input is alphabets, it will go to Q0 to Q1.
Input
And the
is
second
alphabet.
input, if it is alphabets or digits, it will go to finite automata.
So how many states?
3, sir.
3? Okay.
Sir,
Wait,
is it a 2 states? Sir, 2 states.
Yeah, 2 will do.
Yes, sir, because Q0 is a starting state.
Correct.
Q0 to Q1, it is a letter.
It can be letter.
Sir, it is a self loop or like straight
It
letter.
is a self loop. Second state will be self loop.
Yes, sir. Then it digit will be self loop, sir, according to me.
Yeah, digit, not only digit. See, read the question. Recognize identifier beginning with a letter followed by a sequence of letters or digits.
Yes, sir.
So both letters
digits
and
self loop,
digits,
sir.
both letters and digits will be in self loop.
Self loop, sir. Sir.
Yes. Anyhow, fine. We'll discuss in the next class. But think on this. This is how we need to write. We'll take some good examples maybe in the next class. Probably we'll be able to understand how to do it. Okay. Thank you.
Thank you, sir.
Thank you. Yes, sir. Go ahead.
థ్యాంక్ యూ సార్
Thank you.